Alright guys, I had a quick question about a derivative. So let's see here. The derivative we want to talk about right now is the function we want to talk about right now is f of x equals 9x minus 7 divided by the square root of x. Now this question right here is in section 3.3. Section 3.3 is about the product and the quotient rule. So I'm going to solve it using the quotient rule first, but then I'll go back and solve it using another way. We actually can solve this pretty much two basic ways. We can use the power rule from section 3.2, which will require us to rewrite this function first. But let's do the quotient rule first. So let's see here. According to the quotient rule, this would be f prime of x equal to, so we're gonna have a big quotient here. It may be even longer than that. So it's the derivative of the top function, so 9x minus 7, times the bottom function, square root of x, minus the derivative of the bottom function, square root of x, times the top function, which is 9x minus 7, divided by the bottom function squared. So that's what the quotient rule tells us to do. Now we need to take those two derivatives in the numerator. Now what does the denominator simplify to? That just simplifies to x. What's the derivative of 9x minus 7? Well, the derivative of 9x is 9, and the derivative of 7 is 0, so that derivative is just 9 times the square root of x. We then have the derivative of the square root of x. Now, just off to the side, to take the derivative of the square root of x, so let's say derivative square root of x, we first need to write that in exponential form, so x to the 1/2, and we then use the power rule. So this is equal to 1/2 times x to the negative 1/2 power, otherwise known as 1 over 2 square roots of x. Okay? Now I could these two right here are equivalent. They're both the derivative. Now I think that I am going to use this form here, though. I'm going to use the radical form. You can use either way, but I think I'm going to leave it in the radical form because we will need to simplify this compound fraction that we're about to encounter. So the derivative of the square root of x, like we just saw, is 1 over 2 square roots of x. You should probably just go ahead and memorize that because we're going to see that all the time. Times 9x minus 7. Okay, so let's concentrate on that numerator now. We have 9 square roots of x minus 9x minus 7 over 2 square roots of x over x. Now that, of course, is our derivative. We have the derivative here on the second line, but we need to simplify this. You always need to simplify. Just like with most of these, algebra is going to be more of a hassle than the actual calculus. So we need to combine this numerator and then take care of this overall division. So think about this as being 9 square roots of x over 1, and we will need to get a common denominator. The common denominator is 2 square roots of x. So multiply this fraction here by 2 square roots of x divided by 2 square roots of x. So let's see, we're going to have the following. We're going to have 2 square roots of x on the bottom, but what's 2 square roots of x times 9 square roots of x? Well, you have 2 times 9, that gives you 18. And then square root of x times square root of x just gives you x, minus 9x minus 7, 2 square roots of x over x. Okay, we're getting here. We're getting close here. Now we can combine the numerator. That gives us 18x minus, now I use parentheses here, be careful, 9x minus 7. Oh, I didn't give myself nearly enough room there. So let me erase a little bit. So we're going to have 18x minus, now use parentheses, 9x minus 7 all over 2 square roots of x. Everything divided by x. Okay, getting close here. So on the numerator, we are going to have, let's see, we have 18x minus 9x. So that's 9x and then plus 7. So 9x plus 7 over 2 square roots of x. Sorry, that's really small. Then divide by x. Okay. Let's see here. We then need to take care of that overall division. So that overall division dictates that we are going to flip the divisor. The divisor is x, so flip it. We'll get 1 over x and multiply. So we're left with 9x plus 7 over 2 square roots of x times x. Now the last thing to do here is to realize that the denominator can be simplified. We have 2 square roots of x times x. What's the square root of x times x? Well, think about your rules of exponents and think about what exponent the square root of x has. That's like saying x to the 1/2 power. So we have x to the 1/2 power times x to the 1st power. Rules of exponents tell us that that's equal to x to the 3/2 power, since we add our exponents when we multiply two exponential expressions with the same base. Okay, so the denominator simplifies to 2x to the 3/2 power, and there we have it. Okay, so after all that, there is f prime of x. Now notice, at all the work we just did, the only steps right here that are calculus are this one and this one. So this step right here is the quotient rule, and then this step right here we took this little derivative, or excuse me, we took the derivative of here, which resulted in 9, and we took the derivative of the square root of x, which resulted in this. Okay, other than that, all of these steps, all the way down here, that's all just algebra, okay, and some arithmetic, I suppose. Combining the fractions, taking care of the complex fraction, rules of exponents. That's a bunch of algebra and a little bit of arithmetic. Okay, so I keep telling you guys this, that the calculus isn't necessarily the hard part. Yes, you have to remember it and you have to practice it. It's the algebra and the arithmetic that really get folks. Okay, so just make sure to practice this. Now, that's our solution. That's one way to work this problem. The second way to work this problem is go back to the very beginning and rewrite it. We can rewrite this as two distinct fractions. We could write that as 9x over the square root of x minus 7 over the square root of x, which then we could then say is equal to 9, okay, let's think about this. We have x on the top and a square root of x on the bottom. So what would that be equal to? Again, think rule of exponents. If you have x over the square root of x, that's x to the 1/2 power. So x is x to the 1st power. So we have the quotient rule for exponents that tells us that you subtract the lower exponent from the upper exponent when you have exponential expressions with the same base and a quotient. So this is equal to x to the 1 minus 1/2 power, which is x to the 1/2 power. Okay, so we have 9x to the 1/2 power minus 7, okay, if we rewrite that in exponential form, it would be x to the 1/2 power on the denominator but to write that in the numerator only, it would be x to the negative 1/2 power. Okay? So we rewrote f of x, again, just algebra so far, as 9 times x to the 1/2 minus 7 times x to the negative 1/2. Now we can differentiate this function. Okay? If we differentiate this function, let's see here. Let's pick a new color. Oh, yellow will work just fine. We could say that f prime of x is equal to the derivative of 9x to the 1/2 minus the derivative of 7x to the negative 1/2. Okay. Now, let's use the power rule, in this case twice. Okay, we can say that the derivative here is, so let's just take the x to the 1/2. That would be 1/2 times x to the negative 1/2. So we're going to get 9 times 1/2 x to the negative 1/2. Okay, remember this is one of those derivatives I just said you probably should memorize this because we're going to see it all the time. Now we'll simplify that in the next step. But then we have minus, okay, where there's 7 times, what's the derivative of x to the negative 1/2? Okay, the power rule says you bring the original exponent in front of your x. So we multiply by negative 1/2 times x, and then you raise your original exponent, you reduce your original exponent by 1. So 1/2 minus 1 is negative 3/2. Be careful when you're subtracting negatives. You're subtracting 1, and watch those negative signs. 1/2 minus 1 is negative 3/2. So now let's simplify a little bit. Or actually, okay, just to be clear here, guys, we're done with the calculus. That line right there, we are now done with calculus. The rest of this is going to be arithmetic and algebra. So we have 9 times 1/2. That's equal to 9/2. Okay, we then have x to the negative 1/2 power. So we can rewrite that as, actually let me fix this, is 9 over 2 square roots of x. So 9/2 times x to the negative 1/2 power puts a square root of x on the bottom. We then have negative 7 times negative 1, that's positive 7 over 2, so plus 7 over 2. Now x to the negative 3/2, okay, let me back up a little bit. I'm going to actually leave this in exponential notation, and I'm going to change that square root to exponential notation as well. So it was a square root of x. Let's put that in x to the 1/2 power. Okay, so they're both in exponential notation. Now, I want to combine this fraction. Again, this is just simplification, not calculus. If I want to combine this fraction, I need a common denominator. Well, they both have a 2. There's an x to the 1/2 power and x to the 3/2 power. So how might I get a common denominator? I think the thing we need to notice here is that if we multiply by x over x, that will give us a common denominator. Now, why is that true? So we'll get a 9x on top, and we'll have a 2. We have x to the 1/2 power times x to the first power. We talked about that before. The rules of exponents, we have x times x to the 1/2, so that's like x to the first times x to the 1/2. The power rule for exponents says if you have the same base, different exponents, you can add your exponents. So 1/2 plus 1 is 3/2. So our new exponent on the denominator over here is x to the 3/2 power plus 7 over 2x to the 3/2 power. We now have a common denominator, so we can simply combine the numerators, 9x plus 7 divided by 2x to the 3/2 power. Does that look familiar? Well, hopefully so. Hopefully so. We can see here that f prime in its final form is right there. So we have f prime there, and way down here we also have f prime. Are they the same thing? Let's see, 9x plus 7 on the top in both cases, 2x to the 3 halves in both cases. So yes, those are the exact same thing. Again, just to recap, you could take the function as is, use the quotient rule. There's a pretty significant amount of simplification required. Otherwise, you could go and use the rewrite the function, okay? Rewrite it to start with, so do a couple steps of simplification on the front end and use the power rule, then you'll have a little less simplification afterwards. Again, let me just reiterate, the only steps here that are calculus are this step right here, this step right here for the first way we did this. Otherwise, the only steps that are calculus are right here, and that's just a pretty broad, basic rewriting there, nothing crazy there. The main step for calculus was right there. So again, just two steps here were calculus in both of these calculations, in both of these derivatives. The rest was all simplification. So simplification on the front end and back end for both of these. Okay? Let's say real quick that I wanted to ask the question, and again, I'm just going to show you this example. It's not part of the homework question I'm talking about right now, but let's just say we wanted to find the equation of the tangent line at x equal 1. Again, it's not asked in this particular homework exercise, but since that's a very common question, I just want to go ahead and show you another exercise, another example of doing this. So if we want to find the equation of the tangent line at x equals 1, we first need to find the slope at x equals 1. To find the slope, we need the derivative, and then we just need to evaluate f prime of 1. So f prime, so m equals f prime of 1 in this case, because we're trying to find the tangent line at 1. So what's f prime of 1? Well, that's 9 times 1 plus 7 over 2 times 1 to the 3 halves power. Okay, so 9 times 1 is 9 plus 7 is 16 divided by 2 times 1, so it's over 2 equals 8. So there's my slope, it's 8. So to write the equation of the tangent line, I need a slope, which I have right here, and I need a point. Well, there's x right there. The point I need an x comma y. So I need to find the corresponding y value to this given x. Now, a very common mistake is to plug x equal 1 into f prime to find a y value. But that's the slope, okay? So that's not a y value of the original equation. That's a y value of the derivative function. So I need to go back to the original function and find the y value. So essentially we're going to have a point 1 comma f of 1. And I need to figure out what f of 1 is. So we have 1 comma what? Going back to the original equation is up here. So what's f of 1? Well, f of 1 is 9 times 1, which is 9, minus 7. So 9 times 7, 9 minus 7 is 2. 2 divided by the square root of 1. The square root of 1 is 1. So 2 divided by 1 is 2. So the y value here is 2. So here's my point. We'll label it x1 and y1. And here's my slope. So to write the equation of the tangent line, I simply use point-slope form. Just to refresh your memory, point-slope form is y minus y1 equals m times x minus x1. So plugging in for y1, x1, and m, we can say y minus 2 equals 8 times x minus 1. Of course, we need to simplify this, so put it in slope-intercept form. We could say that y equals 8x minus 8, distributing the right-hand side, and then adding 2 to both sides, we get y equals 8x minus 6. So there is the equation of our tangent line at the point 1, 2. Alright guys, so there we are. There is our derivative function. So the red curve, excuse me, that's not our derivative function. There is our red curve, which is the original function, f prime, and the blue line is the tangent line at the point 1, f of 1. Now I guess I could add that point in there, 1, f of 1. So at that green point, there is our tangent line. So that worked out pretty nicely. And there we are. Okay, so we have there. Now, I'll add something real fast for you. Let's look at another function. Right there. Now, what do you suppose that orange function is? That orange function, and here I'll make it dotted. That orange function is the derivative function. It's the graph of the derivative function. So think about what that's saying here. The derivative function is getting really tall, or really high, really large, the closer we get to 0. What does that mean? That means the slopes of our red curve are getting very big as we get close to 0. Now, why does that make sense? That makes sense because there is a vertical tangent line at x equals 0. So all of these slopes right here, this red curve, they are very big. They're almost vertical. Those are huge slopes. So the closer you get to 0, the bigger your slopes are getting. Thus your thus your derivative function is increasing without bound, just as your slopes are increasing without bound as you get closer to 0, that vertical tangent line. Now what's happening as you get further away from 0 on this red curve? So look here, the slopes are leveling off. See the slope here, if you imagine a tangent line, say right there, that has a much more gentle slope, thus a smaller slope, than a point way over here which has a very steep slope, also otherwise known as a big slope. These are all positive slopes, by the way. They're all rising from left to right. But the slope is leveling off the further you get away from the origin. Thus, your derivative function, this orange curve here, is getting smaller and smaller. That is, the y values are getting smaller because the slope of the curve is getting smaller. So again, remember what a derivative function means. The slope of the tangent line right here is given by the point on that orange curve right there. The slope of the tangent line right here is given by the value of this, the y value of this derivative function right here. The slope of the red curve at this point is given by the y value of the orange curve at that same point. So I really need you to, really want you to think about what the relationship here is between the graph of a derivative and the graph of a function, and then of course the graph of a tangent line as well. Hope that's been helpful. If you have any questions, always feel free to ask.